Okay, hello students. Here, this is the Unit 5, Algebra 2, Unit 5, and lesson number 1. So, this is a short unit, uh, all about, if you click on the Unit 5, you will see transformation of the function. So, basically, this whole unit will be about how do we transform a graph, maybe a function, and maybe should we shift the graph to the left or right, up, down, and is there a vertical compression or stretch or horizontal and so on. So this lesson is the first one is basically is only about the learning target the students facing. Let's describe how to transform graphs. So we have to describe. So in the tasks you have completed in the Desmos, I'm sure you have completed all the slides, but here I'm working on only the practice problem. And again, the learning target is today I can describe how the graph is transformed. So this is the basic main goal for understanding how the transformation works. Now, I'm gonna go straight away to the practice problem. There are only 5 questions, so we have a lot of time to show up. I want you to write all the steps that I'm showing you how to go about and figuring out what's going on. Now, practice problem 1, there are 3. In the first question, describe a transformation that gives graph representing G from the F. So basically F is the so this F is the original graph. The blue color is the main. So in each of these 3 graphs, you see the blue color is the original graph. And then the question is, how did we get the green graph? If you see this, there's a green graph there. So how did we get that graph? So what's going on here? Before we begin figuring out, I just want to go to Desmos to show one example of that we did today was square root function. So f of x is a square root function. We've seen this and we also have taken the table and we did this is how the graph looks like. Now I'm gonna take this another function g, but this time in the radicand, if you see that x here, inside I put a plus 3. See this? So there's a x plus 3, and you can stop the video for a while and see if you can guess where the graph will get shifted. Will it get shifted to the right or to the left? Now, usually everybody thinks that because there's a plus 3, students think that it goes somewhere here, starts from this end. Okay, but remember that if you just see what happens is if you let me click on this and see where the graph. So the red graph, okay. Let me take this as the blue graph and this one as the black color. And clearly, so the blue graph is this one, and then starting is 0, 0, so x is 0. This 0 she gets shifted to minus 3. So this is the function because when the input is minus 3, the new function gx in this gx, if you put minus to there, so the original function is 0, 0. That's the f graph. This is the f graph. And this point is minus 3, 0. We want to make sure that it is really correct. Is this really true? So question is this really true? And we can put this as x equals minus 3 there and see what's going on. So let's put g of minus 3, and that is square root of minus 3 plus 3, and the answer is 0, which is the output. So that's correct. So this graph seems to be 100% correct. So all you remember is that the new function, whenever there's a plus 3 inside, so the graph is shifted 1, 2, and 3 units to the left side. So under the radical sign, suppose if I had to write another function, you can see the new function gx is f of x plus 3. If it is the original, but we put a plus 3, it means shift to the right. Or let's say there was a h function and it was square root of x minus 2. What does this mean? Is the graph will shift over here. See, it will move two places to the right. So it goes 1 and 2. So the graph will go something like this. Right? So that's all. There's x input, whichever in the under the radical sign. And if there is a number with a plus sign, it means the graph shift to the left. And if there is a minus 2, and that means the graph shift at 2 comma 0. So this is the understanding of that. So one more observation I want to show here is, let's see, if I want to write another function gx with the original is square root of x, f of x, okay, and then I put plus 3 into the graph. Click here, the graph goes up. So that's like the out plus 3 which moves 3 places up. And if you uh, take away 5, it shift 5 units down. So this is the understanding of this. There is a vertical shift here. So positive moves up, negative 5, negative means moves down. So hope that helps. So this is all about of this today's lesson is about this 4 practice problem, but I'm sure I want 100% we do understand this part, and also about let me take this off and write another function h of x as equals let's put a minus square root of x. So minus square root of x, and you can see the graph, the blue graph reflects over the x-axis. So the minus, the output, they change the sign. And if I take this off and put a so this means reflects over the x-axis. But if I can write another function with radical sign, but this time I'll put a minus inside radical sign, but minus of x. So let's put minus of x. You see, so this is the black one is reflects over the y-axis. So hope that makes sense. So how does this affect? So So this function is basically is minus of f of x here. Okay, this function is f of minus of x. Okay? You're changing this one, and this one I already showed you how to go about. And the earlier one was there was another one, I think put it at mx equals, and then I can write f of x plus 3 means it shift to the left. See, plus 3. So each time there is, uh, if the input is replaced x plus 3, it means it moves to the left. But if the input is minus x here, it reflects over the y-axis. But if there is a number, not the input x stays the same, but there's a number negative 5 by itself, that lowers the graph down 5 places down. So that's the difference between the number next to the input, where the graph either goes, it's called phase shift also, or horizontal shift, either left right. This means up down. This means reflects over the x-axis. This reflects over the y-axis. So let's go now to the problem. So since we are just beginning uh, foundation, so not yet gone to detail. Now, look at this graph. I think you can pause the video and you can decide by yourself what is happening here. Okay, I hope you have decided. And best is, why don't, since the blue is the original graph, and start with the origin. So this graph crosses the origin. So look at the blue color graph. Uh, so this is the main blue color graph, the y equals f of x. And I'm going to start with this point. Look at this point. Where did this point? So This point, where did it go? That's the point. See the shape. You can see this was the original, right? And you can see the green also is something like this. That means it has moved to the left, right? So how many places did it move to the right? Just watch this origin here, and you can clearly see that it goes. Now this is like almost here is like 2, right? This, because in between there is a 1 which is cannot be seen. That's -1. Then there's -3 missing here, so it's 3, so 1, 2, 3, and then it goes 4 places. You can clearly see that here this will be 4, and then another 5. So that's -5. So this, so that's -5. So that means the blue graph has shifted. So I want you to write this word. So the graph f of x has shifted 5 places to the right. That's it. So that's the observation that the graph has shifted. And I want you to also to write how to write what is the relation between gx and f of x. So remember the Desmos activity. So the green graph means which is the gx is the green graph. Let's see, use the color. Mm, okay, that's the green graph. So gx So Gx is, how did we get this green is, it was the original F graph, okay, let's write the blue graph, the F of graph, but this one has shifted to the left. So what I have to do is the input, I have to put +5, see? And you can see whether this is really true. What does this means? You are putting +5. You want to make sure this is really right. And there's a -5 here. Let's put x equals -5 and see what happens. So if you put f g of -5, and put f of -5 plus 5. So this becomes, and from the graph you can see g of -5. That's the point -5 comma 0. So this is 0, and this part is f of 0, that is 0, and f of 0 here is 0, right? So that's the f of 0 here, and that's correct. So this is correct what we did. So this is the relation between the blue graph that you see here and the green graph. The green graph is a transformation of the f of x graph, f of x, was shifted 5 places to the left. Sorry, I made a mistake, to the left. So if it is left means you put a plus sign here. That's all it is. So, and also I wanted to write down here, this is, it is also written as another way to write. Later on, we are going to write gx equals it is f of x minus of -5. So basically, that will be called later on as h. So h is negative. So it's like h is a negative number. So you shift the graph to the left. That's what that means here. Okay, let's go to the second question. Okay, I want you to try yourself first. The blue graph is the original graph. So this is the blue graph, the original graph. And by our visuals, we can clearly see the graph has somehow, I want you to watch this main dot here. So they gave you that 0, 1, and this is 2. So what's happening is that if this is 2, that's a little confusing. It means this number is 2 here. So they are going in terms of 2, 4, and this may be -2 and -4 like that. And if this is 1, then this is like 2. I can clearly see the graph has shifted. So simple this is. Watch this. So this graph has shifted 2 units. This is 2 units. So it moves to the right. So the original function f of x, first it shifts 2 units to the right, and then it goes up 1 unit. See? So from 1 to 2 is 1 unit. So this graph, so how did we get the graph of G? So you have to describe in your own English words. You say, okay, Gx is a graph of f of x. It's a transformation of f of x graph shifted 2 units to the right, units to right, and 1 unit up. So it went 1 unit and shifted 1 unit up. So in other words, you want to write the relationship. Let's see, if I want to write the new function g of x, the green color is, the original was f of x. So you can write first the horizontal shift because it moves to the right. Remember, moving to the right, we are going to write f of in the parenthesis x minus 2. So it moves to the right. So you just do the opposite there, see? And because it went up here, you add plus 1 and see nice relation. So you're supposed to write this one, not besides writing the understanding. Everybody understand this, but can you write this? That's the beautiful, intelligent way of understanding the whole idea of what's the transformation. So the transformation, this means shifted 2 places to the right, and this plus 1 indicates that it shifted 1 unit up. Hope that helps. Let's put this. Okay, so now the blue graph is the main graph. So let me again do this. Blue. So this is the blue graph, right? I don't know why I'm okay. So what do you think? I want you to pause the video for a while and can you try yourself and what's happening? How did we get the this one, the green graph from the what's happening here? Okay. So the first thing is the blue graph in between what we can do, you can first reflect. So if this is the x-axis, the this graph we can first I'll draw in between a kind of let me try. So this is like you're reflecting over the x-axis. So you first reflect over the x-axis. So that's how the thing is. So this point, and then after reflecting, so that in the beginning, remember it was f of x is the original. First, what you do, you reflect. It means you put minus of f of x to this part. And then after that, you move this red color. So this graph, you shift 1, 2, and 3. There you go. So the whole graph goes up and you get a green graph. See? And you get this graph. So that means the next one is it is minus of f of x and then you move plus 4. So the new function, so that the gx is you first reflect. So what are you supposed to write is you in words that this is expression what you are supposed to write. So gx is obtained. So gx is a graph of f of x of f of x reflected. So the first step is reflected over the x-axis and then shifted 4 units up. That's it. That's all it is. Hope that helps. Okay. So let's go to the second question, and there are three more questions there. In the second question, describe the way to transform each graph so that it goes through the labeled point. So what they gave you is you can see there's a cubic function given to you. There's an exponential function given the second one. There's a parabolic function, square function given, and absolute value function. The question is, what are the change? What can we think? What description can make this graph, which you see right here, so that it goes through -1 to +1? I want you to take a moment and see if you can try it yourself and think of what you think is how do I get this done? The easiest way I think most of you must be thinking, as I say, you must have thought, is this is the graph actually, this graph that you see is a cubic function x cube. That's what we did last time. So this graph is like you can say, okay, you want to go through this point, the one that is given you. So I have to go one, or you can say, okay, I go one to the right, sorry, to the left. So you go 1 unit to the left and 1 unit up, and then that means it is something. So something like this. So that's how the graph is. So something like this. So if this is the graph, it goes this way. Made a slight mistake here. Let me do it nice and clean. So this is, so let's do this one more time. So this graph goes this way and then this way, so something like this. So not very nice and beautiful, but I think I can make it a little better maybe. Because the point is this one, so it has to go this way. You can see it goes through one, so it has to go through here. So something like this. And then it has to go through here also. And it goes, let's take a turn and something like that. So that's the graph. This is one way to do it. It means the new function gx is, you can say, okay, it is cube, but you're moving to the left, so you put plus one, and then it goes up, so you can plus. That's one way to do. So the question is there another way to do this? See, I can take off this. I want you to think over this. Can we reflect what if we reflect over the y-axis? So if this is the graph, if I reflect, each of this point will reflect here, this point will reflect here, and then you can see this graph will go something like this. So that's how it is. So the main goal is to check whether this graph is really passes through the point minus one comma one. And there you go. So this also is correct. But if you want to write the new function, we can write here as f of the x cube. But this time we write the new function is gx is f of minus x, which is, so either this, or you can clearly see besides this, you can also think of reflection over this point can reflect here, this point can reflect here, and it's the same kind of thing like this. So this is another way. So you can either say reflects over the y-axis, or you can say, okay, reflect over the x-axis. It means your new function gx will be minus of whatever f of x. So this is how we need to understand. One is this also is correct, or you can say this one, or you can say, so this is also correct. Reflects over the y-axis, or reflects over the x-axis, or you could say it shifts over one place to the left and goes one up. Let's move, check the next. So this is 2b, and clearly you can see it has to go through this, right? So what we can do is, okay, this is the main point we can think of, which is 0, 1, and you say, okay, you go one to the left, and then you go one down, and that's it. So we can say, okay, this one goes something like this. So move it this point, and then we can just do like this here. So something like this. We're done. That's all it is. So we can say the G, if you want to, if you want the original graph to pass to this point, so we can shift the black graph. They didn't say nothing, so I always call the original is f of x, the black one. So that's the graph. We don't know what it is. Maybe 2 raised to x, I don't know. But that's the graph which has, so this original graph, so this graph shifts. So if it shifts one place to the right, one place to the left, okay, and then one place or unit, whatever that is, one place down. And you can get, so if this is the, I'm just taking this 2x, it could be 3x, I don't know. But uh, the main thing is the new function that has to go through this point, the one that is say is nothing but, okay, you write 2 raised to x, you shift one place of plus 1, and you go down. And that's it, it's a new function. or you can write g of x is whatever the original function. If you don't write this expression, you could also write f of x plus 1, and then you go down minus 1. That's all it is. So beautiful. Third one, let's go. So this is the original graph, right? Now it has to pass through this point. So what are the options? Pause the video for a while and see if you can try it yourself. Okay. So one way would be, okay, that's the point, right? So can we move these two places to the right? And then that means this graph will go something like this. So first you uh, move 2 units to the right, and then after that, can you go 4 places down? See this part? Yeah. So if this is the original function, the new one that has to go through, let's see, this one has to go like this. So, mm, so the new function, let's say, this one, it has to go, see? So the green one is the final outcome. So first is, um, in order for in order the graph has to go through the this minus, sorry, 2 comma minus 4. First is the black graph, and I'll call it f of x. So first shift f of x 2 units. Can you see this is 2 units? So it goes 2 units right. So it go 2 units right, and then transpose or shift, and then shift 4 units down, 4 units down. That's it. So you go down. That's one way to do, or you can say, okay, the new function gx is you move the original function, you move 2 places. So you put -2, and then you're going down 4, so you put -4, and that's it. Or another student may say, hey, no, I don't want to do this way. You may think another option is, why don't you just reflect the whole thing? Look at this. This is 2 and 4, right? And this is 2 minus 4. So you can very well just reflect this whole graph, like this. So it goes like this exactly. So this is one way to do. Or you can say, okay, another way to do is just reflect over the x-axis. So when you reflect over that, you just put minus of f of x, because that's the original one. This is the original function which you reflect over the x-axis, and then you just put a minus sign. That's it. You're done. And basically, this is nothing but the square function here, and you just have to do this become minus of x squared, and then that's it. You're done. Let's go to the last one. Watch this problem. I want you to pause this video for a while and see if you can figure out how can this absolute. Now, this is the absolute value function, and you know the absolute value function is this one, right? Uh, Question is, how do I make this go through those 2 points which are shown here, this point and this point? So how do I, what can be done here? So many of you must be thinking, oh, Ribello, why don't you go just 2 down? So 1 and 2 down, and you see, does this really work? And you can see, if you do this way, it goes. Okay? So you just by shifting, so that if this is the f of x, so shift, I would say, f of x, shift f of x 2 units down, 2 units down, and that's it, and it goes. It means the new function is nothing but the original function, which is f of x. But this time you are putting -4. That's what you're supposed to write. If you really want to use this way, so the new gx is nothing but you put absolute value function, put a -4, you're done. My point is this the only way, or there's another way to do is, I want you to watch this. It's a little challenge for you guys. This is a point, right? Now this point has gone here, right? See this part? In other words, this is the original function. The output here is 4 comma 4. So this 4 is changes to 2. If you see this part, this point changes to, if I try to, I want to know if I can look at this. Look at this part. So this number is 2, 2, right? So it now it becomes 2 and 1. So what do you notice about what's happening to the output here? So the output, which is 2 right here, become 1. This 4 changes to this 2. So that means we can write another new function instead of this. This is one way to do, but we can also write, it's like called vertical compression. And what is vertical compression is you kind of write gx is the 4, the output 4 now is 2. So that means it becomes half of the original function. See, this is such a beautiful way to describe this. There is a vertical compression, we say compression by scale factor. So that's the scale factor by scale factor half, which means any output, again I repeat, this output which you see, this output which is 4 comma 4, now this 4 change becomes 2. That's what I'm trying to say. So hope that helps just to look at a different perspective, that it is like the word, so you are just compressing this graph towards the x-axis and the y values change. Let's go to the third question. So even though your hard copy doesn't show you these colors, but the blue graph is the original graph and there are dots shown, describe a way to transform each graph so that it matches the data. So there's a data there. So how do you the blue graph matches the data? How do I try to get the blue graph, make almost close to that graph? So that's our question. So let me uh, take the snapshot. So the blue graph is the original graph, and you can pause the video for you to try yourself, and then now you can check. So I'm gonna make this graph the blue the this one I'm making a graph, and you can guess something like this, and almost the same thing. See, so original function is the blue. This is the blue graph, and you can clearly see that let's see this point. I want you to focus on this point and this point. What's happening? There's one point, oh, and you can see it goes 1, 2, 3, and it goes 2 up. This also is 2, so you could go 4 right and 2 up. See, you can think of this point and this point also. If you see, it goes 1, 2. Did I mean? So let me check if I mean. No, this is 3 right, right? So it goes 3 right. So we got 1, 2, and 3, and then it goes 1 up. Oh, sorry, 2 up. So 2 up. So in other words, if the original function was f of x, so the green function, how can we get a green function? What changes can we do to the blue graph is green graph, the closest that you can think of the blue graph, so the f of x, so shift, we can say, if you shift the graph 3 units to the right, okay, you move 3 units to the right and 2 units up, 2 units up, and then it works. See, so that's why I said 3 to the right. So how do I write that new function? I want you to get used to this. So it means if gx is this one, the green one, so we can write the f of x which is shifted to the right means you have to put -3, and then it goes 2 units up means +2. See, such beautiful. And you're done. That's all it is supposed to do in this example. Hope that helps. Okay, what do you see here? The blue graph. It looks like the blue graph is the f of x. The original graph is like 1 over x rational function, right? So that's the rational function. Now I want to know what's happening here is the the green. You see this green? It's like the same graph. It looks like shifted something to the right and then goes up, right? So can we think of where did it move? So if you see the blue graph, this is the point we can think has gone somewhere, maybe it's gone somewhere here. Can you see that? So that's the point. It means Let me clean this off. So basically what I'm trying to say is the blue, this point, which even though it is not part of the graph, but I'm just using it for in order to get the origin type. See, the actual graph of the rational function is this way, and I'm just putting this as like a center kind of thing, so like this one. So just to show that this one moves somewhere here, which is 2, 1. It means this graph moves 2 to the right and 1 up. So what's happening is if this is the original function f of x, the new function is g of x, the green graph is shifted f of x to the right. So you write -2 and then you go 1 plus 1. That's how it is. But if you want to use this one, you can write it as is. The g function is wherever the x is the input, you put x -2 because you're moving to the right, and then you add +1, so you put +1. And that's how you're supposed to understand this. Hope you guys get it, and then go another one. So pause this video and then see if you can figure out what's happening here. So the best thing is think of this point is well, first what I do I will reflect over the x-axis. That means if this was f of x, so when you reflect it becomes minus of f of x, right? Then I'm going to bring this, move it to the right side, somewhere here 1, 2, so I shift the graph, something like this. So that's like, this was already reflected over the x-axis, and now you're moving to the right, so you put x -2, and then after that, the final one is the green color. You go 1, 2, 3, 4, and 5. So it goes 5 up. So that means the last one is the gx graph is, so first reflect over the x-axis, shift to the right, and then add +5. And see, such a beautiful expression you get. And this is how we are supposed to write. So if you want to get from the blue graph, you want to get a graph that is close to all this data. So you have to first reflect this blue graph over the x-axis. Then after reflecting, that's how the expression you get. You move to the right and you get the red graph. And then after getting the red, you just shift it up. And that's it. Hope this helps. Okay, look at this is question number 4. What does the function f or g, which one is the better one, the blue, or you guys have to decide yourself. And if you look at it, if you watch closely, it looks like the green graph. What this green graph is, even though it does not touch, it is going almost close to those dots data on this side, maybe going a little down, but eventually it passes also through the data point. So I would say the GX graph uh, fits the data better. Both functions show overall trend of data, but G matches the data better because the points are closer in general. So you can see these are all closer in general to the graph of G than they are to the graph of F. So the G is where they are more closer to this. That's all you're supposed to write. I want you to write in your own English words for this graph. So this question is from Unit 2, Lesson 3. Now, since I'm working on Unit 5, so I'm going to skip this, so you don't have to do this. So I'll just skip this part, okay? So hope if you, in order to get full points for the work that you show, make sure you write all the work in the hard copy that is provided. And please understand those things. What I said is, if f of x is the original function, then you have so many things are happening. I want you to write this. So gx could be minus of f of x. Gx could be f of minus x. Gx could be either f of x, and then let's say minus h, like this, where h is some positive, okay, some positive number. So it's like shifting to the right or gx could be f of now if it is positive, or it could be also if h is negative. So it depends. H is negative. So if h is positive, it moves right, and if h is negative, moves left. That's what that means. This is reflection over the x-axis. This means reflection over the y-axis. And if I write f of x and plus some k, and then again here k could be positive and negative. So positive means up and negative will be down. So these are the only things you're supposed to remember. They look confusing, but please get that. As we progress this week, eventually you're supposed to get. Thank you very much for watching, and hope this helps the video to understand everything. Thank you.